I'm an assistant professor of computer science and electrical engineering at UMBC. So today we, created this plan for this session to give you an idea about how you can start your, career in data science, or if you want to learn, teach yourself data science, what kind of resources we believe you should follow. And this is part of the series that UMBC is organizing, Pause and Pivot. Um, so like today, we are talking about data science. Next week, we will be talking about trends in the labor market. Um, and please sign up for our future events if you are interested in those. But since the time is very limited, I just want to jump into the subject. First, these slides are available as a PDF file. I just uploaded them to my GitHub repository. So the link is at the bottom. Maybe Rex can, or maybe just first let me copy and paste it in the and go to the chat and share the link with everyone. So if you want to download them, for future, usage. Okay, let's
And
close
also
chat.
share that you will all get a follow-up email with the slide deck and the recording after the session.
Oh, that's great. That's great. Okay. All right. Again, the purpose is if you are interested in learning data science, studying data science, then applying into your own field. Today we will cover all the basics, what kind of resources are available, and I will give my personal advice. Of course, everyone has a different opinion, but so far, I can safely say that this formula really works for our current students. Let's start with some basics. So what is data science? What is machine learning? How companies are using it or using them. Okay, for the first question is, of course, very simple. What is data science? I believe every person who works in the field of data science, they have their own definition. But a couple of years ago, National Academy of Engineering and Sciences, they came up with this definition. So it is knowledge discovery from often large and complex data sets. And it is interdisciplinary by nature, encompassing statistics, computer science, applied math, and domain-specific tools. So if you have a background in computer science, that's really great. But you don't have to have a background in computer science to become a data scientist. So the field of data science is huge. And let me tell you just one very quick story. So one of my old friends from Turkey, he was working at Oracle's data science team. So I went to their office in Arlington, and since this is a data science team, I was expecting everyone to have a PhDs or master's degrees in computer science, doing some cool stuff. But then I learned almost maybe 75% of them had backgrounds in different fields. Some of them math or statistics, but some of them public policy, some of them arts. I was really surprised, but as I spoke to them, then I learned, and we all learn again, the field of data science is huge, and there is a need for every kind of talent. And we will explain why that is the case. So again, it's a combination of a little bit of statistics, a little of programming, a little bit of math, but it is also very important to have this domain-specific background. Like someone who has a background in chemistry, right? They can learn basics of data science, and then they can apply for jobs for companies like pharmaceutical companies. Like if you have a background in biology, you can apply for jobs at NIH or NIH contractors. If you have a background in public policy, World Bank is a great place to work for. So never say, oh, I don't want to my background is not important. Your background is extremely important, and you can really use it as a main feature to build your data skills on. Let me tell you this at the actually very beginning, because there's a significant difference between data science and machine learning. So in data science, what we do is our focus is, so we work with data sets and we try to learn something from those data sets. by using the techniques developed by like machine learning experts. Okay, so like we don't have to be an expert on developing algorithms. That's not our job. That job belongs to the people with PhDs or master's degrees in computer science or in machine learning. Okay, and to implement these data science techniques, um, we just need basic knowledge and experience in programming. But it would be really nice if we can improve our site skills, for example, with dealing with like different types of data sets or different types of visualizations. Okay. Um, to me, the most important thing is having like a genuine interest in using data science for your own company or for the company that you are working for. But again, like if you have an interest and if you have some fundamental skills, you can definitely teach yourself data science. So here we are not the main aim is not creating or educating the people for the new generation of machine learning models, but instead using the existing models and then uh, you know um, you know doing like improving this, whatever the thing that you want to improve for your company or organization. So I'm like if you are here, probably you are aware of this, but data science grew so fast in the last 20 years. And the question is like why? Like why did this happen in the past 20 years? And to me, there are like four main reasons. The reason number one is actually very simple, right? The amount of data we are generating is just growing exponentially. Oh, by the way, just turn this on. Our cell phones, like, we are taking pictures. We have all those GPS devices. They are collecting our location. We use applications to buy, make like online purchases. Like, so all of them are like pieces of data. And again, since the mobile devices the number of mobile devices are increasing um, exponentially, the data we are generating exponentially is growing exponentially, so that it is giving us huge opportunities to dig into that data and come up with like new learnings. So that's number one. Number two is actually, oops, sorry. Number two reason is the data storage, right? So on the right, you see like a giant capacitor, which was like a hard drive made by IBM. It was storing 5 MB of data, and back then it was costing $50,000. Now you can go to Amazon and you can buy a 1 TB of like USB stick, which is like $70. And of course, now we have this SSD technology, which is like extremely fast. So now, like, we are producing lots of data. We are storing it, at a much lower price and at much smaller volumes. And the third thing is now, like, before we only had like CPUs, like central processing units, right? Now we also have tools like GPUs, like graphic processing units, or TPUs, tensor processing units. So these are specifically created for like dealing with or like making operations with matrices. And in machine learning, we do tons of matrix operations. Just for example, like doing CNNs. So these bad boys really help us to accelerate the running our codes with hundreds of times. Okay. So now we are running our codes much faster. We are using so much data. We are storing this data for cheap. And the number four reason, to me, it's another, maybe it's the most important one, is everything in the field of data science. It is just, freely available. If you want to, write a code, Python is free, R is free. If you want to write this code, let's say you don't have a fancy computer, that's fine. You can just use online platforms like Google Colab to write your codes. You don't have to you don't have to share your files or outcomes through Google Drive or Box, right? Which might not be open to public. You can use like freely available GitHub like repositories like GitHub to share your outcomes. So everything, but everything in the community of data science is freely available. And the other thing is, like, as I told you before, like data science communities are welcoming. They are open to everyone with all these different backgrounds, and they share. I come from the field of like computational, like photonics, electromagnetics. We write codes all the time, but we never share. Like all those codes stay in our own computers because that is the only success that we have, right? But data science community is not like that. Everyone is just sharing what they have. And like, for example, in Python community, the last time I checked, the number was 150,000. So there are 150,000 freely available modules to do almost anything. Like if you want to write your own function, you are more than welcome, but probably someone else has already done that code and you just import that function, then you run that code, okay? So that is the other thing, that data science community is extremely welcoming. Give me a second. So, like, if you like, actually, we can try. We can just go to LinkedIn right now and check how many data science jobs are available right now. But I chose one example, like a case study, like where data companies use data science for their business. And this company is, of course, like Amazon. They are a big company, they're an extremely successful company, but they are using data science for every single function of Amazon. Like, for example, like they create personalized recommendations by using machine learning techniques. So they work with companies to sell their products to. So they have other type of algorithm. They use other type of algorithms like clustering algorithms to determine the right audience for that product. They are doing lots of optimization to forecast the demand, right? Which products will be favorable in the following weeks or actually following months, right? And then which warehouses. So when you order something, if it is not available at the nearest the warehouse to your house, then it has to be delivered from another warehouse to the different one. So there is this route optimization based on the demand, also based on the availability, and also expiration dates of the products. They need to do dynamic pricing. So they use natural language processing techniques to determine the fake reviews or like fraud attempts. They also again use NLP, like natural language processing, to do sentiment analysis, right? So when you look at the reviews of products, you see there's like a summary, like customers think about this product, and this is good, this is bad, right? That is called sentiment analysis. Now, like they also use computer vision, which is a part of deep learning, right? So you go to these Amazon Go stores, there is like no one. You just buy the product yourself, you scan them, you get out. So that computer vision, like understanding what product you buy, is all AI or machine learning. Voice recognition on Alexa is another deep learning method. And the last example is like robot coordination that they use in their warehouses. But look at this, one company doing and using all different techniques of machine learning to improve their service. Okay. Let me give you a very quick overview of a typical data science project. So let's say like we work at Amazon and we have a goal, right? Our goal is, I don't know, let's say we would like to minimize the costs related with moving stuff from one warehouse to another warehouse. So the first step is like business understanding and having a goal, right? Let's say our goal is reducing this cost by 10%. So, now we have a goal, and I'm sure like Amazon has tons of data sets. So what we need to do is we need to first do some like data mining, right? What does this mean? This means that we should maybe determine the products which are most frequently were transferred from one warehouse to another one, or the ones the products which required the most longest routing, right? So we have to first play with the data, okay, and see what kind of parts of that data set we should work on. But then in step 3, like there will be some issues in our data sets. For example, some products will be like no longer available or replaced with other ones, right? So we have to dig into our data set and do some like cleaning, like maybe like removing some not already like current existing products from our data set. Then, like in that data set, there will be like lots of columns, or like maybe it's like a relational database. There will be so many pieces of information. But which parts of information are important for us, right? For example, customer name, we will not care, right? But the price that the product was sold is important. The location of the buyer, location of the warehouse one, location of the warehouse two. Like, so we need to spend some time to understand which features are the most important for us. Then we can build our like models. So like model building, it sounds kind of difficult in the beginning, but once you learn the basic techniques, you will see that it is like just one line of code for making a model, another line of code for making a prediction. And in the last part, like it is like data visualization, right? You should create really easy to understand, but at the same time fancy images, so that our bosses, our managers can understand and the main message that we want to tell. But like overall, it's a like step-by-step process. And in this field, like right now, actually you can see even from this image, like we need people who has the right business understanding. We need people with some basic programming skills to do, like for example, data cleaning. We need people who are experts on creating images. We need people who have knowledge about statistics, so they can say that, all right, like in this model, the p-value of 0.05, I'm just making it up, means this, right? Like we have this 5% maybe uncertainty in our data set. So again, like this is a very typical cycle of a data science project. And as we just discussed in the previous slide, seriously, like all the big companies are using data science right now to improve their services. So before we go into the next steps, so I just want to quickly go over the there are like three main sub areas of machine learning. Like these are called supervised learning, unsupervised learning, and reinforcement learning. And there's this very common example of understanding like what is supervised learning, what is not, what's unsupervised learning. So in supervised learning, like we will have data sets with perfect labels. For example, here we have a red apple, it says apple, the label is apple. We have another green apple, which is green, the label is apple. And the third one is a banana, right? So we have the pictures, and then we have their labels. So what we will do is we will use these pictures as our input to our learning model. But so X, like the input, will be the images of these fruits, and the outputs would be the labels like apple, banana. So we can use different machine learning techniques to do the training. And once we are done with the training, then we will be doing the testing with the data set or pieces of data which were not used in the training process. For example, we will show this green apple and we will ask, is this an apple or banana? And if we are successful enough in our learning model, it will say, oh, this is a banana, right? So this is supervised learning. So we have data set with perfect labels. And we use supervised learning techniques for classification, regression, making estimates or prediction. And there are a bunch of techniques to do these. So you can just use simple linear regression, or you can go advanced. You can build neural networks. So they all have cons and pros of their usage. For example, like linear regression, it is so simple. It is very intuitive. The training time is very short, but the accuracy might not be very high. On the other hand, neural networks might require longer training time, but since they can identify the hidden patterns in the data set so easily, they can be extremely successful, like accurate. So that's supervised learning. So unsupervised learning is slightly different. So you have a data set, but you don't have labels. Okay. it is the job of the algorithm to understand what kind of stuff that we have in this data set. So again, in this case, we will not tell anything about the like the type of these fruits. We will just provide the pictures. Then the learning algorithm will say, hey, like the first two fruits, they look similar to each other, even though they have like different colors, but their shapes are similar. So let me make them group one, and the other fruit group two. So when we show the third, like when we do the testing, we just ask what group this new apple belong to, right? So it then this fruit belong to. So if our model is successful, it will say, okay, this belongs to group one. So this is extremely important for, like, for example, customer clustering, right? Like real estate business use this a lot. So they have pieces of data about people, but they don't have the labels, right? But they just want to categorize people in different categories so that they can sell the right product to the right group of people. So that's the unsupervised learning. Okay. We can use like k-means algorithm. We can use Gaussian mixture model or other stuff for doing this unsupervised learning. It's very common. And the third technique, main technique, is like reinforcement learning. It is extremely useful for decision making. Okay, but it is too advanced for this short seminar talk. So let's skip it for a moment. But like the field of the data science, the field of machine learning is big. But if you are a data science enthusiast, or if you are someone who wants to learn about data science, like we don't have to learn the deep theory behind these methods. We just need to learn their basics, how we can use them, like when we should use them, right? For example, like if we have this certain question, should we use linear regression or should we use logistic regression? There is a huge difference between them, and you can learn, you can teach yourself these basic techniques like easily. So in the second part, I will just focus on like different resources, like, because as we said, data science is big. I don't want you to get lost. I really want you to get like a good roadmap and use the right resources to teach yourself data science step by step. Give me 1 second. So by the way, I found this picture online, like on Google. So it's not my figure. I apologize for that mistake. I should have mentioned the website. I found this picture, but I like it, like how to learn, how to self-learn data science with all the best free resources. Okay. So to me, this is the right roadmap, and I think you should start first. You should start with improving your programming skills. You might not have any programming skills. That's okay. You might be an absolute beginner, but I think that's the starting point, because like we would like to do data science, right? We would like to do some statistical analysis. We would like to use some machine learning techniques, but doing what? By using our codes, right? So that's why coding should be number one. In industry, like 75% of the companies, they are just using Python. It's free. It is very easy to learn. But in healthcare and biology, they are mostly using R. R is also freely available. It's very simple to learn as well. But you should, again, like first start with learning Python programming. Then second step, which is actually which would only take maybe 1 week of yours, should be like database management or like query engineering. Okay, so there is this data set somewhere in the cloud. You don't have to build a model to do some analysis, but you just need some pieces of information, or maybe a basic analysis, like EDA, exploratory data analysis. So how can you do that, right? Or yeah, so like database management or working with the files in the cloud. I think it should be your step number 2. So while you are learning Python programming, while you are learning about databases, you can spend some time on statistics and probability, and I will show you the best resource ever created to learn statistics and probability for doing the data science. Once you have established, these, fundamental skills, then you should learn about, data science techniques, right? But again, there are so many of them. So I think you should go step by step. And I will give my the favorite list of subjects in a specific order. So once you are comfortable with these techniques doing some Python programming, then you should work on sample projects by yourself, produce some results, and then you should share these results with the greater audience. So I call it like production. So you should do some data science by yourself, but you should share those results of yours online in a real professional manner, so that when you apply for a job, people can just click that link where you showcase them, then they can see what you have produced. Okay, that's really important. You know, you can say that like on your resume, I know Python programming. That's one thing. Versus like I know Python programming and these are the codes that I wrote. And please go to my GitHub repository and check them. Right? Then that will be also evidence. Okay, so let's talk about the best resources to learn Python programming. Again, these are my own personal opinions. So, some people like following a very structured you know structured structured like courses, and like there are so many courses out there, right? There are so many free online courses, but to me, if you're a absolute beginner, the best course is the one offered by Coursera. uh okay, let me try to share my maybe screen. Okay, hold on, let me just stop this, stop sharing, and let me go to share my whiteboard. What's this? No, screen. Okay, screen one, no, screen two. Okay, let me share my screen two. And there, I want to click this link. Oh, it opened the other screen. All right. So I'm going to take this to here. Look, this course was developed by University of Michigan people. You can enroll for free, like just today. So if you want to get your certificate, then you have to pay some money, but you don't have to get a certificate. Like the important thing is like learning, right? And if you look at the course content, that there are like 5 sections. First, getting started with Python data structures, like using Python for like dealing with the data available online, then using databases with Python. So like it is, I don't know, 36, it's like 60 hours of work. But this, if you just follow their content, you will definitely learn all the fundamental stuff that you have to learn about Python programming. Okay, so that's a really great resource. The other resources I would recommend would be like some YouTube tutorials. Some people like my wife, she likes watching YouTube videos instead of reading by herself. So I think to me is the best one is the one created by Corey Schaffer. So if you like, let me just check, click this link. Oops, don't go. So like if you look at the subjects, right, it says Python tutorial for beginners, like installation and setup. Then big strings, how to work with strings, how to work with integers. So it's very well organized. And again, it gives you all the fundamentals that you need. So there's a more not like unorganized YouTube channel, but I really like Sandex. So in this one, there are so many short videos, but you have to do your work. Like you have to read the titles and you have to choose what you want to learn. But I also like, again, like this channel. It is very informative. The third resource, which is actually my number one resource, is Python documentation. Like Python documentation is very well written with all the examples that you will need. It is like a like a book actually, right? So let's go, for example, like 4 statements, right? It just says, okay, I'm going to, like, for example, here it says we will have like a list of words, and then there will be like a for loop, right? But again, like the important thing is Python programming. So like Python programming is great, right? that's what we do all the time. So if you want to start today, that is super simple. Like you don't have to have again, like fancy computer. What you need to have, what you need is just a Gmail account. Okay. If you go to collab.research.com, right? Uh, so collab.research.google.com. So it's there like a new screen. I'm just going to create like a new notebook. Okay. Now, like we are in Python. So like this is a called like notebook. Um, it it's not like writing just one piece of code. There are like cells. In each cells, you can write some short amount of codes. Then then uh, you know like you can go step by step, and you can run an entire code. But again, like Google Colab is a platform which allows us to run our Jupyter notebooks running those Python codes for free. There are so many great things about uh, yeah, Google Colab, which is one of them is actually runtime type. So if you click here, it says that which hardware you want to use. Do you want to use CPU, which is slow? Do you want to use GPU or TPU? So GPU and TPU are fast if you are doing, again, like machine learning stuff. But the thing is, Google doesn't allow you to run so many GPUs and so many TPUs at the same time. Like if you are running codes at the same time, that 2 or 3 is max, depending on the number of operations they are running. So like Google Colab is just great. Okay, you can practice your Python skills on Google Colab on cloud. That's great. The other thing, other free resource is called like Anaconda. So the nice thing about Anaconda is you just download a package, you install it, and in that package, Python is already there. Okay, so you just click, then you're already there. That later I will share like another resource with you. Because it explains like where to download Anaconda, how to install it, after installation, what happens. So I will talk about it. But if you want to the Anaconda is good if you want to run the codes on your local machine. So it could be like a Chromebook, it could be like a laptop or workstation. So in that case, the nice thing is like as I told you, that Google only allows you to run two or three codes at the same time. On your local machine, you can run as many codes as your RAM allows. Okay, I'm going slower than I expected, so let me a little bit speed up. So my recommendation about Python programming is first, get familiar with the concept of notebook. What's a Jupyter notebook, right? Go to Google Colab or download Anaconda and open your Python interpreter. Then you should learn about the data types. Okay, that's the most basic thing. Like, so we have like lists, we have tuples, we have dictionaries, we have arrays, etc. So you should learn about data types like strings, integers. Um, then the third is learning how to write like if statements, if else statements, or like for loops. And the fourth is like working with different type of data sets, like different files, like text file, like TXT, or CSV file, or Excel file, like new ones, right? So once you are comfortable with like basic operations, creating an array, writing an if statement or like a for loop, then you should get familiar with the most important 3 modules of Python. NumPy, like numerical Python, Matplotlib, which is visualization, how to plot like 2D, 3D, different types of visualization skills. And then doing some basic exploratory data analysis. So here, let me click, follow this link. So this was a like Python workshop like we used to run at UMBC, and then all the resources are here, like again available. You can download the Python note like Jupyter notebook. You can open this notebook in Google Colab. Um, there's also like HTML version of these, right? So it says like so these are HTML version of those notebooks. You can just copy and paste. Okay, like for example, if you just copy this, go to your notepad, just cancel. You can say this. It will run your code. Okay, but like on this workshop, we talked about let me see, like how to install Python, how to do like Anaconda. So like if you just, oh, this is an old link, so I need to just remove distribution. Oh, no. Okay, just the anaconda.com. I have the updated list. Okay, products, Anaconda distribution, Cloud Suite, okay, distribution. Oh, now you have to, okay, free download, but you have to give your email address to them. All right, so like that's my recommendation for learning Python. Again, like you can go to my website and you can download those materials free. Because like again, on that website, the one thing I like is actually we have those slides. So let me open the slides. Ooh, different page, different screen. Look, it says, these are the links. Once you install it, you need to like just press launch here so you can run Jupyter Notebook. And then blah blah. Okay, it just explains. So this is like a 2 days workshop on Python programming. Okay, let's go back to the subject. Oops, sorry. Okay. Once like you are learning Python programming, if you want to test your Python programming, there is this beautiful platform like kaggle.com/learn/Python. So there are like Python tutorials, but also there are some like simple projects for practicing data science and machine learning. Okay, I strongly recommend Kaggle. But in fact, Kaggle has all the other resources that you will need about not only programming but also databases, machine learning, etc. So it's a really great platform. But it is so big, so you might get lost if you don't have a nice plan. But again, this is a great platform. Third thing is that getting help from AI. I do this every time, every day almost. I write some codes. Sometimes they work, sometimes they don't. If I cannot figure out my bug, my error, I just go to ChatGPT and I ask. I say, "Hey, ChatGPT, this is the code I wrote. It fails. I don't know why. Find the bug or help me with finding the bug and fixing the bug." So ChatGPT is good. There is this Chinese version, DeepSeek. It is really great also. In fact, in terms of writing a code, it is slightly better than ChatGPT. We have like Gemini. It's not better than ChatGPT, but sometimes it also produces nice codes. So for example, what you can do, right? I just did this. I went to, I think this is ChatGPT. Like write me a Python code that outputs arithmetic and geometric means of a provided NumPy vector. Then press enter, and it just writes this function for me. And in the end, it also gives an example, like, oh, by the way, you should just copy and paste this example and test it. So like AI is a big helper for us to learn and test our learnings. Okay, the following thing is database management. So like I'm not the database person. I don't know much about it, so I cannot comment much about this. But our Data 604 instructors, I asked them, and they told us, these are the best courses and tutorials. So IBM's free course on SQL or SQL is the best one to learn how to manage data, how to work with databases. But there is also this great YouTube channel. I forgot their name, but they have a very nice, very well structured set of courses, videos about the basic use of working with SQL, right? How can you make a query in a data set available in the machine or in the cloud? And there is even a dedicated AI platform. You can just go there and ask, like, how can I, for example, merge two data sets, like two relational databases to achieve this? Okay. And it's extremely successful. Since it's only created for SQL inquiries, you can basically get your exact answer from SQLchat.ai whenever you want. Okay, so the third component, statistics and probability. So I will first share two resources to learn statistics and probability, but the best one is the third one, which will come later. And I strongly recommend you using the third resource. So the first resource I would recommend learning statistics is Python Academy. So if you click this link, you will see a very well, like nicely, structured course talking about first like means and medians, then z-scores, what is correlation, what is like sampling theorems, what's a p-value. Like, again, everything you need to learn about the statistics and probability, which is important for data science, is there. Okay, this is a free course, great course. I really recommend you if you want to brush up your skills in statistics. But there is also another, again, if you're a YouTube person, there is this channel, StatQuest, and they have so many short videos. Again, like these are created for very beginners, and they're like nice, organized. So you can just watch them if you have like free time. But when it comes to learning statistics for machine learning, the ultimate source is ISL, Introduction to Statistical Learning. So in the beginning, when I took this online course 8 years ago, there were these two professors that you see on the right, one from Stanford, one from, I think, Berkeley. And they are really experts on statistics. One of them is expert on the theoretical part. The other one is expert on programming. And they created this series of lectures. They are freely available on YouTube. They have a book which you can download for free in PDF, as a PDF file, freely available. And another very nice feature is all the codes that you will need to run those examples, they are freely available, both like a Python codes and also R codes. Okay. So this 8 years ago, when I decided to learn about data science, I seriously just sit down in front of my computer, took my guitar, I just watched all the videos once. They are short, like 50 minutes, 20 minutes. So the videos are not only like thoughtful, educative, but also so funny. Like really, these guys are hilarious. But then I said, okay, now I want to implement whatever the subjects they cover by myself. And back then they had only codes in R, so I wrote my codes in MATLAB. But it was a really great experience, and actually this course was the starting point of my research in the field of machine learning. So I strongly recommend this resource to you. ISL, okay, Introduction to Statistical Learning. Now, like the newer version of ISL, there are like 4 professors, so they included 2 young fellows with them, but the core is the same. Okay, now let's talk about the data science techniques. I believe you need to learn fundamentally. But like data science is huge, and there are so many data science machine learning courses. But to me, the best one is the one created by this very famous person of machine learning, Andrew Ng's. So this is a series of courses. Okay, so he has one part of course focusing on supervised learning, another unsupervised learning. Then he also covers the advanced techniques like neural networks. Why do we use like CNNs? Why do we use RNNs in his advanced section part? But this course should be taken at the very end. Like you should be comfortable with statistical concepts, comfortable with Python programming, like doing a little bit of database engineering, management stuff. Then you should take these courses. Okay. And to me, the right path is as follows. First, you should learn linear and logistic regression. So these are the very simple 2 methods that we use on a regular basis. And they are the most intuitive and easy to implement, to understand, to do the basic EDA, like exploratory data analysis. So after regression, I think you should learn about KNN, like K nearest neighbors, and how we use decision trees. So this will actually be enough to do lots of machine learning. But since now we know a little bit more statistics, we can also use Bayes' theorem, and then we can implement probabilistic classification using naive Bayes. Support vector machines are great. Principal component analysis are extremely important for feature extraction. Random forest, I'm not a big fan of it, but in some cases they are useful. So like these subjects will be definitely so important and so useful in your career or in your future work doing some machine learning. But after these, some fancy methods are created. For example, gradient boosting machines or XGBoost. This will come like later. So you don't have to understand the super big logic behind them, but you have to understand like what is like boosting. How can I maybe determine the optimum boosting parameters? Like it's called like hyperparameter, uh, determine like optimization. Um, but you know, I think like deep learning should come right after, like way over after these. Okay, deep learning is much more complicated. It's definitely understandable, right? But I think you should learn deep learning at the very end. I see so many people they try to start their data science career right from deep learning. Okay, so I think that's not the ideal way of you know learning machine learning. So, now let's say, you are comfortable with Python programming, statistics, you learn the basic techniques of machine learning and data science. Now you should play with some different data sets based on your background or future plans, and where to find these data sets. So my most three common data set resources are UCI, like University of Irvine ML repository. They have very well structured data sets with very nice explanations. They're all available freely, of course. Kaggle datasets is great. And Google has a dedicated search engine like dataset research. I'm sorry, datasetsearch.research.google.com. Just go there and enter your subject. For example, I'm just going to make it up, like sound database dataset about like birds. Okay, like you just Google it, and then it will show you the most relevant resources. But since we are living in the Washington, Baltimore area, the government is, or at least was, a big employer. So they share their data sets at data.gov. So if you are seeking for a employment at the government, I would recommend working with their data sets, right? So if you are, as I told you, if public policy or economics is your field, World Bank is a great place to work with, and they also have their own data sets. United Nations, same. National Ocean and Atmospheric Administration, they have tons of data sets. NASA, and also like Zillow. Like Zillow has this very famous data set. It is real, like how to determine the optimal price of a house. Okay, so these are some resources to find data sets, right? So you should pick your data sets of your interest, then practice. And once you started to produce some results, you should share those results with the greater audiences. How you can do this? You can just use online free places. So my favorite is GitHub. The basic usage is free. So basic means like I cannot upload files more than 25 megabytes, but all the smaller files, they are more than welcome. And using like learning the basic use of GitHub is super simple. It will not take more than 10 minutes. Okay, so let me just maybe share my screen. Let's go to GitHub. GitHub. So this is my repository. Like you can see, I have right now 30 different like folders to share data. So if you want to create a new one, you just go to repositories. After, of course, creating an account, you say, I'm going to create like a new folder, new repository, right? You just click, you give a name, you provide like explanation. You can make it a private or public folder, then you're done. Okay. So I'm just go back, like for example, here we have a repository, right? If you want to add file, go to that folder, then come here and say, I'm going to add a file. You can create a new file manually, or you can just upload files from your computer. Okay, it's super simple. For example, right before this meeting, I just came to here and I okay, open this. I just so like these are the slides that I'm using. If you go to right upper corner, you can just say, ooh, say like download the raw file, then you can download the PDF file. Okay, so it is very nice platform, and you can learn the basics again in 10 minutes. But Git and GitHub is actually much more than this. You can do, like, when you work in teams of data scientists or other people, so everyone will make some small portion of the code or the algorithm or the method, right? So how you can make sure that all those subroutines that you are writing, they work together, or how can you maybe like roll back to the former model or create like a new branch. So again, so in order to work in teams, I think you need to learn Git. And again, there are so many nice resources to learn Git. But again, this is too advanced for the moment. And another very nice feature I really like is actually you can use GitHub as as your website. Okay, I'm just going to share this link. Okay, that's fine. So you can create like very fancy websites. So you can have a picture of you explaining what you are doing. You can share your code. But when you share your code, please make sure that you have brief explanations. You have some colorful figures. Again, like there's a great, there are so many great resources to create your free website by using GitHub. All right, so that's all I want to say. Thanks so much for your attention. It has been like 54 minutes, 55 minutes. If you have any questions, please, you are more than welcome to ask. I will be more than welcome to, I will be more than happy to answer those questions. All right. Any question from anyone?
I think the folks feel like you answered all their questions. So, you know, appreciate you, Ergen. This was very informative for me. Feel like I got a lot from just, listening to you. But if folks do want to come into the chat, if they don't feel comfortable coming, off of audio, please feel free to include any questions you have there. But I will reiterate, everyone is going to get a copy of this recording as well as a copy of the slides. And we have or you could pull it up, the last slide that links them to the exit survey. We'd love feedback on this.
Yeah, sorry, absolutely. Yeah. Let me share my screen again. Go screen 2. Okay, let me go to the other screen. Yeah, this is our last slide, right? Sorry.
So if you have folks who want to just scan that on their phones and let us know what we can do better, what we can continue to keep doing, or maybe change for you all, especially as this was our first hour-long session. Want to get some feedback on, what feels good for folks. Do you like these more in-depth approaches, or do you like 30-minute sessions we've been doing up until now? But let's take a look at the chat, see if anything does pop up.
Okay, if there's nothing in the chat, that's fine. Yeah, again, thanks so much for the attention. I hope, like, now you have a little bit more motivation to learn data science, then use it for your career, for your future, for your company, for your employees or bosses, and just be productive. That's what we do.
Thank you, everyone. Look out for the follow-up email and enjoy the rest of your afternoons.